All of us have smartphones which we use regularly and they can access everything that's personal and private to us. Now, generally, we focus on installing apps from the private app stores, right? And the assumption is that these stores, these official app stores like Google Play or Apple App Store, have certain security analysis techniques in place that make sure that these applications are secure and they are not doing the right things. Now, generally, for security, people use cryptographic APIs. So, confidentiality, integrity, all these things are done using cryptographic APIs. And whether the developers are doing the right thing in their applications, they check it by things called cryptographic API misuse detectors or crypto detectors in short. So in this work, we actually focused on raising this research question. Are these crypto detectors working in the first place? If not, then why? And how do we figure that out? Like, how do we know that they are working in the first place? Because clearly benchmarks are not good enough. People can game benchmarks really easily. Anyone can emulate a benchmark's behavior and then make sure that their tool will always work and will always get 100 out of 100 with respect to those benchmarks. So, to start our research, we actually started with the cryptographic API misuse in the wild. We analyzed the sources from industry and academia and extracted all the misuse that we could find from those sources from the last 20 years, and this is the accumulation of what we have found. This has been done after 2 months of manual work where we have analyzed and extracted everything. And this contains all the cryptography API misuse that has been discussed in industry and in academia. Now that we know what cryptographic API misuse means, we can simply create a benchmark. Yes, but that is not going to be useful again because that can be gamed really easily. Any tool can be fooled really easily, or any tool can actually fool the benchmark really easily. So that's where the mutation comes in. What we do is we create mutation operators that can mutate the cryptographic API misuse. That is, they create the different variations of the same misuse so that they look different but behaving the same way. So now that we have mutation operators and we have misuse, we can mutate them and put them in applications which are from the wild, like open source applications, open source Android apps, all those things. Now that we have mutated applications which contain those, we simply analyze them using the target crypto detector. And if it finds all the mutated flaws that it introduced, it's good for them, they're doing the right thing. But if they don't, that means that they are not doing things perfectly and they have some kind of security issues or they have some kind of flaws that is preventing them from finding those misuse variants. And as part of our work, we actually went back to the developers to figure out what is going on because we wanted to understand why they are not detecting this misuse in the first place, which is where the title is like this, why crypto detectors are failing, right? So when we discussed with them, we found some really interesting insights. The perspectives are really diverse when it comes to creating this crypto detector. Some of them are like, we don't consider it as a flaw because that kind of misuse, we do not see it in the wild. And some of them were like, we will consider it as a misuse when we see it frequently in the wild, which means that they have this implicit assumption about frequency. Like, how do you define frequent observation in the wild? Is it 100 times, 100 million times? We have no idea about that. So that implicit assumption is bad for security. So in our work, what we propose is that since we are depending on these analysis techniques for our security, and they themselves are claiming that we should use these tools for security auditing, for compliance certification, all of these tools should be subjected to hostile reviews, which is where this framework, this mask framework comes in, because it subjects these tools to hostile review, and by helping us find flaws in these tools, it actually helps them build better tools. So this work has been sponsored by the National Science Foundation as well as Commonwealth of Virginia CCI, and it has been accepted in the IEEE Symposium on Security and Privacy. So I have already presented it there, but you're most welcome to explore the paper as well as the presentation that's available in the YouTube and in my website, Labs website, and everywhere. Thank you.
Thank you so much, Amit.
Yeah, gracias.